Have you ever wondered why don't rocket nozzles melt? Rocket engines burn at over 3,000 degrees Celsius, hot enough to melt steel. So why doesn't the nozzle melt? First, rocket nozzles are made of heat-resistant materials like niobium or copper alloys. But that's not enough. Even the best metals would fail under that heat. As it turns out, it's cooled using a network of tiny tubes all around the nozzle, carrying liquid nitrogen at negative 240 degrees Celsius. This super cold nitrogen absorbs the heat and keeps the nozzle from melting. This keeps the nozzle structure strong while allowing the engine to keep firing. Without this cooling system, the nozzle would burn through in seconds. And that's how rocket engines stay cool, even when generating millions of horsepower. Next time you see a rocket launch, remember, it's all about smart engineering. This is the most expensive hobby of all time, and it's definitely not for kids. Sure, a beginner RC plane might cost around $1,000, but that's nothing. For true enthusiasts, a single plane can cost well over $100,000. And yes, these planes have real jet engines and everything. From hydraulic systems to landing gears, they have all the features of a real aircraft, just on a smaller scale. At this point, it's more than just a hobby, it's a competitive sport. Events are held throughout the year where passionate experts bring their creations to compete, showcasing everything from massive models to military replicas. And these aren't toys you can just buy off the shelf. They're handcrafted by passionate experts who spend years perfecting their builds, where every flight is a high-stakes moment. One wrong move, and thousands of dollars can go up in smoke. That's what makes this hobby so thrilling. It's not just about flying, it's about engineering, precision, and the adrenaline rush of controlling a miniature jet-powered masterpiece. Like and follow for more. The biggest construction project in history has officially started, but experts are saying it could be a massive failure. New satellite images show entire worker villages are popping up, while older ones are literally being wiped off the map. We're talking about the line in Saudi Arabia, a 170-kilometer-long, 500-meter-tall city with mirrored walls. It was originally supposed to cost $500 billion, but now some experts think it could skyrocket past $1 trillion. Even with Saudi oil money, that's a ridiculous amount of cash. They say 9 million people will live here. But let's be real, who actually wants to move to the middle of the desert? And because of its linear shape, traveling from one end of the line to the other could take hours. Plus, there's the biggest problem of all. Building a 500-meter-high mirrored wall across shifting desert sands? That's an engineering nightmare waiting to happen. So what do you think? Is this the future of cities or a mega flop in the making? Let us know in the comments. Watch how this CL-415 refuel its massive tank in seconds. When it comes to fighting fires, this thing is an absolute monster. It's built specifically for one job, dropping tons of water on wildfires, and it does it better than any other plane out there. It doesn't even need an airport. It can scoop up over 6,000 liters of water straight from a lake or river in just 12 seconds, while still flying. That means no waiting around, no refueling stops. Its weird shape allows it to fly low, dodges mountains, and dives straight into the smoke like it's nothing. The high wings and powerful turboprop engines keep it steady even in the roughest conditions, places where other firefighting aircraft struggle. That means it can fight fires where helicopters and bigger planes can't even go. Oh, and it's not just water, it can drop fire retardant foam too, making it even more effective at stopping flames before they spread. That's why countries all over the world, Canada, France, Italy, Greece, and more, rely on the CL-415 to battle massive wildfires, places where other firefighting aircraft struggle. That means it can fight fires where helicopters and bigger planes can't even go. This is one of the largest industrial diamond factories in the US. It makes polycrystalline black diamonds, one of the hardest materials in the universe. These aren't for jewelry. They're built for tough jobs like cutting marble or making frictionless gears that can last hundreds of years. The process starts with a tiny diamond seed and secret ingredients. It's placed in a capsule, then heated to 2,500 degrees and crushed under extreme pressure. This transforms it into a super hard diamond. Finally, the mold is blasted with sand, leaving only the diamond behind. Because the only thing that can cut a diamond is another diamond. Follow for more insights. Some of you asked me in the previous short about why do space rockets have second stage, or even sometimes a third stage? Will it not be just added weight with the extra engines, electronics, and heavy release mechanisms? Well, believe it or not, this way it can carry more payload weight for longer. When a rocket launches, it needs to overcome Earth's gravity and reach orbit, which requires a lot of fuel. If the entire rocket were a single stage, it would have to carry all the fuel it needs from start to finish. along with the heavy empty tanks and engines that become dead weight as fuel is burned. By using multiple stages, a rocket can drop off empty tanks and engines once they are no longer needed, making the remaining vehicle lighter and more efficient. This staging process allows the rocket to accelerate more effectively and carry a heavier payload into orbit. For example, the first stage is designed to provide maximum thrust at liftoff when the rocket is heaviest. Once its fuel is depleted, it is jettisoned, and the second stage ignites, taking over with a more optimized engine for high-altitude flight. In some missions, a third stage is used to push the payload even farther, such as deep space missions or geostationary satellite deployments. Without staging, rockets would require an impractical amount of fuel to reach orbit, significantly reducing the payload capacity. This is why almost all modern space launch vehicles use multiple stages to maximize efficiency and performance. This is the coldest place in the known universe, and it's not in outer space. It's a new unit from Microsoft's quantum computer, and they claim it's 10 septillion times faster than today's fastest supercomputer. And this is actually the future. Quantum computing is opening up new possibilities that were once thought impossible. So why such extreme cold? Quantum computers use qubits, and they need extreme cold to stay in their delicate quantum state. That's why scientists use liquid helium and advanced refrigeration to create a super deep freeze, just a fraction of a degree above absolute zero. That's colder than space itself. Like and follow for more facts. This is the world's biggest solar farm, and believe it or not, those aren't solar panels, they're actually mirrors. This vast solar complex consists of 4 individual plants spread out over an area of 7,400 acres and uses a total of 800,000 mirrors across its various phases. These mirrors track the sun and reflect sunlight onto the central receiver tower. This giant central tower is where all the concentrated sunlight is focused. Inside the tower, molten salt is heated to temperatures of up to 1,000 degrees Fahrenheit. This salt can also be stored in large tanks and used to generate steam even after the sun sets. Experts say this method is more efficient and might be the future. What do you think? Is this the future of clean energy? This is 3D house printing, and it's becoming more common than you might think. Building a house the old-fashioned way takes months, sometimes even years. And let's not forget the high costs, delays, and tons of wasted materials. On the other hand, 3D printing can build a house in just a few days with minimal labor. In fact, all it takes is 3 people on site. Plus, the technology is so precise that there's almost zero material waste. All this means a lower cost of construction, which translates to more affordable houses for the public. From affordable housing to disaster relief shelters, 3D printed homes are changing the way we build. Some countries are already using this technology to solve the housing crisis.
Have you ever wondered why jet engines do this before landing? This is the thrust inverter, also known as reverse thrust. In simple terms, is a system that temporarily redirects an aircraft's engine thrust forward, helping to decelerate the plane efficiently. Without thrust inverters, aircraft would require significantly longer runways, increasing the risk of runway overruns. Most modern commercial aircraft use either a clamshell or cascade-type thrust reversal system. Clamshell doors physically block and redirect engine exhaust, while cascade reversers use vanes to change the airflow direction. Both systems achieve the same goal, slowing down the aircraft safely and reduce the stress on wheel brakes, improving their lifespan and reducing maintenance costs. Also, they enhance safety by shortening the landing distance, which is crucial in emergency landings or wet runway conditions. If you enjoyed this breakdown of thrust inverters, make sure to like and subscribe for more fascinating insights.